Hello everybody and welcome back to another Algebra 1 video. Today we'll be finishing up Chapter 2 with lessons 2.6 and its extension. These two lessons mainly focus on writing equations in different situations. So we'll go ahead and begin with lesson 2.6, which covers writing equations in point-slope form. Let's go ahead and take a look at what point-slope form. So a linear equation written in the form y minus y1 equals to m times x minus x1 is in point-slope form. The line will pass through the points x1 and y1, and the slope of the line will be m. So if we look at our equation right here, we have it color-coded. So y minus y1, that's going to be the y coordinate of your point. M will be your slope, and then times x minus x1. x1 will be your x coordinate of your ordered pair. Y and x will just remain as they are in the equation. I'll go ahead and show you an example so that you can see how to write an equation in point-slope form. So write in point-slope form an equation of the line that passes through the point -6, 1 with a slope of 2/3. Now, recall that you're going to first plug in all your values. In this case, you're given a coordinate -6, 1 and a slope of 2/3. So you know that -6 is your x and 1 is your y. In this case, label them x1 and y1, and this will be your slope or your m. So now that you know where you're going to plug in your values, you could go ahead and do that. So y minus y1, so that would just be y minus 1 equals to m, which is your slope 2/3 times x minus x1. Now you see here that your x does have a negative in front of it, so make sure you're still accounting for that negative whenever you're subtracting. So that would be x minus -6. Now, if you simplify this, you get y minus 1 equals to 2/3 times x plus 6. Your minus and your negative will just turn into a plus, and you're left with this equation. Now, this is the point-slope format, so you don't have to isolate y or anything. Whenever you're asked to write your equation in point-slope form, it'll look like this, and you're done with this problem. Let's go ahead and move on. So we have, right, in point-slope form, an equation of the line that passes through the given point and has the given slope. So once again, we're given a ordered pair and then our slope, we have 1, 2, and then we have a slope m equals -4. As always, I'm just going to go ahead and label the variables that we're going to plug in into the equation. So for example, 1 here will be x1, and then 2 will be y1, and then m equals -4 will just be m. And now that you know what you're going to plug into your equation, I'll go ahead and plug those in. So y minus y1, which is 2, equals to your slope -4 times x minus 1. And now that you've done that, you already have your equation since we're looking for point-slope form. Go ahead and try this one on your own. Pause the video and unpause when you're ready. Let's go ahead and go over it. So we're going to write in point-slope form an equation of the line that passes through the given point and has the given slope. So we have the ordered pair 7, 0, and a slope of m equals 1. So I'll go ahead and label all my values that I'm given here with what variable they represent. So for in the case of the ordered pairs, 7 is x1, and then 0 will be y1. And now that you have them all labeled, go ahead and plug them in. So we have y minus y1, which would just be 0, equals to your slope, or m, which is 1, times x minus x1, which would just be 7. And now that you have all your values plugged in, you can see that it adheres to point slope form. So this is your final equation. Okay, try this one. Go ahead and pause the video and unpause when you're ready. We're going to write another equation in point slope form given these points and then our given slope. So we have -8, -5 as our ordered pair. That's going to be our x1, y1 ordered pair. So I'll go ahead and label -8 with x1 and -5 with y1. And then once we've labeled all those, we can go ahead and plug them into the equation. So y minus y1 would just be y minus y1 is actually -5. So make sure to put -5 in parentheses, equals to your slope, which is -3/4 times x minus x1, which would be -8. So make sure to put -8 in parentheses. You can see here that we haven't quite simplified everything yet. So point slope form, I have y plus 5 equals to -3/4 x plus 8. Now that we no longer have anything that we can possibly simplify and still adhere to point slope format, we know that we have our final equation, which would be y plus 5 equals to -3/4 times x plus 8. Okay, let's go ahead and look at a new situation. We have, right in slope-intercept form, an equation of the line that passes through the points 2, 4, and 5, -2. Now we still are going to be using the point slope form formula, except there are a few additional points when you're creating a slope-intercept form equation. So we see here in this case that we're actually given 2 points, 2, 4, and 5, -2, rather than outright giving us the slope. So we're going to have to first solve for the slope. Recall that whenever you're given 2 points to find the slope, you're actually going to use the slope equation, which is y2 minus y1 over x2 minus x1. Now you can label both of your points, either ordered pair 1 or ordered pair 2. You can do whichever. I'll go ahead and do 2, 4 as my ordered pair 1, and then 5, 2 as my ordered pair 2. So this would be x1, y1, and then 5, -2 would be x2, y2. Then go ahead and plug that into your slope equation. So that would just be -2 minus 4 for y2 minus y1, and then over 5 minus 2. Once that simplifies, you get -6 over 3, and that can actually divide into -2. Now that you have your slope, you can plug this into the point slope formula. You're going to take one of the points to go ahead and plug into point slope form. So for point slope form, you really only need one ordered pair. So go ahead and choose whichever you would like, 2, 4, or 5, -2. It doesn't matter, you'll still get the same result. I'll go ahead and do 2, 4 for this example. So let's bring out our point slope form equation, which is y minus y1 equals to m times x minus x1. So we have our slope m, or -2, and then go ahead and order and label your ordered pair x1, y1. So 2 will be x1 and 4 will be y1. And now that you know what you're going to be plugging into point slope form, go ahead and plug it in. You're left with y minus 4 equals to -2 times x minus 2. Now, This would be finished if they were asking us for a point slope form equation. However, recall that they're looking for slope-intercept form. Slope-intercept form is in the format y equals mx plus b, where m is the slope and b is the y-intercept. Also notice how y is completely isolated. So let's go ahead and find a way to isolate y and also adhere to the mx plus b format. So first, I'm going to go ahead and eliminate the parentheses here for the -2 times x minus 2 by doing distributive property. That leaves you with y minus 4 equals to -2x plus 4. This is actually this makes the process of isolating y a lot easier once you eliminate the parentheses, because notice how you can now add 4 to both sides. If you add 4 here, go ahead and combine like terms. You can see here that 4 plus 4 can combine, and you're left with an equation in slope-intercept form, which is y equals to -2x plus 8. Let's do another one very similar to the last one. We're going to write in slope-intercept form an equation of the line that passes through the points -2, 1, and 3, -4. So first of all, let's go ahead and find the slope. So we'll go ahead and take out our slope equation, which is y2 minus y1 over x2 minus x1, and go ahead and label -2, 1 and 3, -4 as ordered pair 1 or 2. I'll go ahead and just make -2, 1 ordered pair 1. So that would be x1, y1, and then 3, -4 as x2, y2. Once you know what you're going to plug into the slope equation, go ahead and do that. You have -4 minus 1 over 3 minus -2. Again, make sure you're accounting for the negative in the equation and also the negative in your ordered pair. So you're left with -4 minus 1 equals -5 over 3 minus -2. That would just be 3 plus 2. And you're left with -5 over 5. Your final slope will be -1. Now that you have your slope, go ahead and use point slope form to now plug in values. Go ahead and choose one of the ordered pairs here, either -2, 1 or 3, -4 to plug into point slope form. Again, it doesn't matter, whatever you would like to choose. I'll go ahead and choose -2, 1. And label my coordinates as x1, y1. So now that you know what you're going to plug in, lay out your point slope form formula and then plug it in. So y minus y1, which is 1, will equal to our slope -1 times x minus x1, which is -2. So you're left with -1 times x minus -2. You can see here that you can go ahead and simplify this portion and make it to -1 times x plus 2. And now that you have it in point slope form, you can go ahead and start making it into slope-intercept form by first distributing -1 and eliminating the parentheses. So -1 times x is -x. And -1 times +2 would be -2. And now that you've eliminated your parentheses, you can go ahead and finally eliminate your -1 here and finally isolate y. And then add 1 to both sides. Look for common like terms. You can see here that -2 and +1 are both constants. So you can add 1 to -2. And you're left with y equals to -x minus 1. Go ahead and try this one on your own. It's the exact same thing we've been doing for the last 2 examples, just with different points. pause and unpause when you're ready. Okay, so we're gonna write an equation in slope-intercept form with the points -5, -5, and -3, 3. First, go ahead and find your slope. I'm going to go ahead and label -5, -5 as my first ordered pair, so x1, y1, and then -3, 3 as my second ordered pair, or x2, y2. And then plug it into your slope equation. Y2 minus y1 will be 3 minus -5. And then x2 minus x1 will be -3 minus -5. So this minus of a negative number will turn into a plus and cancel out the negative. And you're left with 3 plus 5, which would be 8, and then -3 plus 5, which would be 2. 8 over 2 can simplify into 4. And now that you have your slope, you can go ahead and pick out one of your points so that you can plug it into point slope form. In this case, I'll go ahead and do -3, 3. So our point slope form equation is y minus y1 equals to m times x minus x1. Now that we've chosen one of our points, go ahead and label them as x1, y1. Now that you've done so, you can go ahead and plug in all your values. So y minus y1, which would be y minus 3, equals to your slope m. So that would be 4 times x minus x1, which is -3. Go ahead and eliminate these additional brackets by simplifying x minus -3 to x plus 3. And now that you have it in simplified point slope form, go ahead and make it into slope-intercept form by first distributing 4 to x plus 3. Once you eliminate the parentheses, you're left with y minus 3 equals to 4x plus 12. Now go ahead and isolate y by adding 3 to both sides. Go ahead and look for like terms, and you can see here that positive 12 plus 3 can make 15. And you're left with your final equation, which is y equals 4x plus 15. You can go ahead and pause the video to do this last example and unpause when you're ready. We're going to write in slope-intercept form an equation of the line that passes through the points -8, 6 and -2, 9. Now this is going to be the same procedure as we've been doing. So we're going to go ahead and first find the slope. So let's go ahead and take out our slope equation and then label our ordered pairs as either ordered pair 1 or ordered pair 2. It doesn't matter which one is ordered pair 1 and which one is ordered pair 2. Just make sure that you are plugging in the correct values. So now that I know what to plug into my equation, let's go ahead and do that. So y2 minus y1, 9 minus 6. And then x2 minus x1 is -2 minus -8. So now 9 minus 6 is 3 over -2 minus -8. The negative cancels, and that creates -2 plus 8. And now you have 3 over 6, and 3 over 6 can reduce into 1 over 2. Now that you have your slope, we're going to go ahead and use the point slope form formula. Go ahead and choose one of the points to plug in for your coordinates. I'm going to go ahead and choose -2, 9, and then I'll label them. -2 is going to be my x1, and positive 9 will be my y1. Now that I know what to plug into my equation, go ahead and write down point slope form. Now you can go ahead and do y minus y1, that would be y minus 9, equals to slope, which is 1/2, times x minus x1, and that would be x minus -2. Now go ahead and simplify this portion by canceling the negative out and making it x plus 2. So now you have the standard point slope form equation, you can go ahead and now create this into a slope-intercept form. So go ahead and distribute 1/2 to x plus 2. You're left with y minus 9 equals to 1/2 x plus 1. And now that you've eliminated your parentheses, go ahead and isolate 9 by adding, or y by adding 9 to both sides and combine like terms. 1 and 9 both don't have a variable, so they are constants. And you're left with your slope-intercept equation, which is y equals to 1/2 x plus 10. That is it for lesson 2.6. We're going to go ahead and move into 2.6 extension. Once again, we're going to be writing equations, but this time we're going to be writing them for parallel and perpendicular lines. So recall that the slope of parallel lines will be the same, and the slope of perpendicular lines are negative opposite reciprocals, meaning they have opposite signs and they are the reciprocal or flipped of one another. So example, if you have a slope of 1/2, the line perpendicular to that will be negative because this is positive and we want it to have a opposite sign, and then it will be flipped of 1/2. So the line perpendicular will have a slope of -2. Now this is really important because we're going to need slope for all our equations whenever we're writing them. And here we're going to be using slope-intercept form or point slope form to write equations of parallel and perpendicular lines. In this case, I'm going to be showing you all of the examples in slope-intercept form since we covered point slope form in the previous lesson. But if you find that you prefer point slope formula, you can go ahead and carry out those procedures just as you have done in the previous lesson on these examples. Let's go ahead and take a look at our very first one. So we're going to write an equation of a line that passes through 6, -2, and is parallel to the line y equals 1/2 x plus 3. Now, very first thing we want to do is we want to find the slope. We're actually going to write an equation of a line that is parallel. So we know that the slope is going to be the same. So since the slope is y equals 1/2 x plus 3, we want to write it parallel to that equation. We see here that the slope is 1/2. So we know that our slope is also going to be 1/2. So now that you have your slope, you can go ahead and plug this in to either your slope-intercept form or your point slope form equation. I'll go ahead and use slope-intercept form. So recall that they actually gave us a point here, which is 6, -2. We're going to use that to create our equation as we've done in the previous lesson. So 6 will just be your x in your y equals mx plus b equation, and then -2 will be your y. Now the purpose of plugging these values into the slope-intercept form equation is to ultimately find your y-intercept, or b. Now you already have your y and mx to plug in, so go ahead and do that. Y is -2. That equals to your slope 1/2 times your x coordinate 6. And now you can go ahead and simplify this. 1/2 times 6 is just 3. So you're left with -2 equals to 3 plus b. Go ahead and isolate b to find your y-intercept. So you just subtract 3 from both sides and you get that b equals to -5. Now you can see here that you have both your slope and then also your y-intercept. So go ahead and plug it into your equation to create your final linear equation. So y equals mx plus b, you're just gonna plug in your slope and your y-intercept. So your final equation would be y equals to 1/2 x minus 5. Let's go ahead and do another one very similar to that one. We have write an equation of the line that passes through -2, 1 and is parallel to the line y equals 3x minus 4. Okay, so we're gonna first find our slope. Once again, we're finding for the line that is parallel. So let's go ahead and lay this out. We know that the slope of the equation that we're trying to write a line parallel to is y equals 3x minus 4. The slope is 3. Parallel lines have the same slope, so our line that we're writing the equation for will also have the slope 3. Now you can go ahead and find your y-intercept with your slope-intercept form equation and use the given point that they have provided for you, -2, 1. -2 will be your x, 1 will be your y, and you can go ahead and plug this into y equals mx plus b. Y will be 1 equals to your slope m, or 3, times x, which is -2 plus b. Go ahead and simplify 3 times -2. That gives you 1 equals to -6 plus b. And to isolate b, go ahead and cancel out your subtraction sign by adding 6 to both sides. And you're left with b equals to 7. Now that you have both your slope and your y-intercept, go ahead and plug it into your y equals mx plus b form. So your slope is 3, so you have y equals 3x plus your y-intercept 7. And that is your final equation. Go ahead and try this. It's exactly the same as the previous 2 examples we've done. So we're going to write an equation of the line that passes through 6, -3 and is parallel to the line y equals -2/3 x plus 5. So go ahead and first find your slope. So the equation that we're given for reference to make our other equation is this one. We can see here that the slope is -2/3. And since we're writing a line parallel to, it's going to have the same exact slope of -2/3. Now go ahead and find your y-intercept with your slope-intercept equation. And I'm going to go ahead and use the 0.6 -3, which is the one that they provided for us. 6 is x, -3 is y. Go ahead and plug in all your values. You're left with this. -3 equals -2/3 times x times 6 plus b. And -2/3 times 6 can simplify into -4. And now you can go ahead and isolate b by adding 4 to both sides. That gives you 1 equals b. You have your y-intercept, you have your slope. Go ahead and plug it into y equals mx plus b to create your final equation. So your final equation will be y equals -2/3 x plus 1. Go ahead and pause your video to try this one and unpause when you're ready. So we're going to write an equation of the line that passes through -4, -5, and is parallel to the line y equals -4x minus 1. Now we're going to go ahead and first find the slope. We know that the equation that we're writing is going to be parallel to y equals -4x minus 1. So the slope will just be the same. So our slope will be -4. And now taking the slope that you found, and then your provided ordered pair, -4, -5, plug those values in to your slope-intercept form equation. So -4 is going to be your x, -5 is going to be your y. So you plug those values in and you have -5 equals to -4 times -4 plus b. -4 times -4 can simplify into 16. And then you can go ahead and isolate b by subtracting 16 from both sides. You're left with b equals to -21. And as always, once you have your slope and once you have your y-intercept, you can go ahead and plug that into y equals mx plus b to get your final equation, which will be y equals -4x minus 21. Let's look at this next problem. We have write an equation of the line that passes through -3, 1 and is perpendicular to the line shown in the graph. Now we're going to do the same exact process as we've been doing for parallel lines, except for perpendicular lines, we know that the slope is going to be negative opposite reciprocals. So rather than taking the same slope as our other line, we're going to go ahead and switch the sign and also flip the numbers. So we're actually given a graph here, so we can go ahead and just count the rise over the run. Start from your leftmost point and make sure that you're using two solid points that have clear values. So I'll use 0, 5 and 1, 1. Now go ahead and count from your leftmost point your rise. In this case, we can see that we're going downward for our rise, so we know that it's negative. And also our line is going up and to the left, so it's going to be -4 units. And then your run is just 1. So your final slope is -4. Go ahead and record that. However, recall that we're doing it for a perpendicular line. So to find the slope of the graph, you're going to have to make a -4 into a negative opposite reciprocal, meaning that you change the sign from negative to positive and flip 4, which is just 4 over 1, into 1 over 4. And this is going to be the slope of your equation. Now that you have that, go ahead and plug this into your slope-intercept form equation and make sure that you're using the point that they gave you for that line. We know that the line passes through -3, 1. So go ahead and plug that into your equation to find the y-intercept. -3 will be x, 1 will be y. That'll give you, I'll go ahead and use point slope form in this situation. Again, you can use slope-intercept form, y equals mx plus b, or point slope form, which is this. Whatever you find better or is easier for you, go ahead and use that. For this one, I'll go ahead and use point slope form. So y minus y1, so y minus 1 equals to m, which is 1/4, times x minus x1, which would be x minus -3. So go ahead and cancel out these brackets by simplifying it to x plus 3. And now you have y minus 1 equals to 1/4 x plus 3/4. In this case, I already made this x plus 3. Then went ahead and distributed 1/4 to x plus 3. And now you can go ahead and add 1 to both sides. 3/4 and 1 are both constants. You can go ahead and find a common denominator. 1 over 1, you can just multiply by 4 over 4. That would give you 3/4 plus 4 over 4. And you're left with 7/4. So your final equation in slope-intercept form is y equals 1/4 x plus 7/4. Okay, we're going to write an equation of the line that passes through 4, 2 and is perpendicular to y equals -1/3 x plus 1. Similar to some of the previous examples we did, we're actually given an equation this time, and we know that this line is going to be perpendicular. So go ahead and lay out your slope. The slope of the line that is perpendicular to the one we're writing equation for is -1/3. We're gonna have to make this into a negative opposite reciprocal since we're making a perpendicular line. Change the sign in front. In this case, it's negative, so make it positive. And 1/3 flipped is just 3/1 or 3. So your slope is going to be +3. Now that you have your slope, let's go ahead and take out our point slope form equation. We're going to use the point that we were given that says that the line passes through 4, 2. So go ahead and use 4, 2. 4 will be x1, 2 will be y1. Now you can go ahead and plug these values into your equation. So y minus 2 equals to 3 times x minus 4. Now you can go ahead and distribute 3 to x minus 4 to cancel out parentheses. You're left with y minus 2 equals to 3x minus 12. And to isolate y, go ahead and add 2 to both sides. -12 plus 2 are both constants, so they can combine into -10. Now you have your final equation, which is y equals 3x minus 10. Go ahead and pause the video to try this one. It's exactly the same as we've been doing for the last two examples, where we're given a point and then a slope and find the line perpendicular. Okay, we're going to write an equation of the line that passes through 0, -1, and is perpendicular to y equals x minus 6. First, I'm going to find the slope. So whenever you don't see a variable in front of, a constant in front of a variable, so the coefficient is missing, just assume that it is 1. So the slope of this line is going to be 1. However, we're trying to make a line that is perpendicular to it. So I'm going to go ahead and find the negative opposite reciprocal. Whenever you're trying to do that, think of it in terms of fractions. So 1/1, we have positive 1/1. Switch the sign to negative, and 1/1 is still going to remain the same as 1. So the negative opposite reciprocal is -1. Your slope is found. As we said, it's -1. So now go ahead and make your equation using the point that we're given, 0, -1. Again, I'm going to use point slope form here. 0, -1 is going to go ahead and be 0, which is our x1, and -1 is going to be our y1. So y minus y1, so y minus -1 will equal to our slope -1 times our x minus our x1, which is 0. And now you can go ahead and simplify y minus -1 to y plus 1, and then go ahead and distribute -1 to x minus 0. 0 can go ahead and cancel out since it doesn't have any value. And then -1 distributed to x would just be -x. And now you can go ahead and isolate y by subtracting 1 from both sides. And your final equation is going to be y equals to -x minus 1. One last one for you to try. We're going to write an equation of the line that passes through -3, 7 and is perpendicular to y equals -2x minus 5. Go ahead and pause the video and unpause when you're ready. First, we're going to go ahead and find the slope. We're given an equation of the line. So it would be y equals -2x minus 5. We're trying to make a line that is perpendicular to this. So we know that the slope of this line is -2. So make a negative opposite reciprocal. So the negative opposite reciprocal of -2 would be positive. And then 2/1 would be 1/2 flipped or as a reciprocal. So your slope will be 1/2. Now go ahead and take out point slope form equation. Now that you have your slope, then go ahead and plug in the point that they provided you. -3 will be x1, 7 will be y1. Go ahead and plug it in. Y minus 7 equals to positive 1/2 times x minus -3. X minus -3 will just become x plus 3. And now you can go ahead and distribute 1/2 to x plus 3. You're left with y minus 7 equals to 1/2 x plus 3/2. And now go ahead and add 7 to both sides to isolate y. 3/2 plus 7 are both constants, so those can go ahead and combine. Go ahead and first find a common denominator, which is 2. So 7 times 2 is 14 over 2. And 3 plus 14 equals to 17 over 2. So your final equation will be y equals to 1/2 x plus 17 over 2. That was it for today's lesson. As always, all information for the lesson request form, tutoring, and any additional practice are going to be linked in the description box below. Thank you so much for watching, and I hope to see you on the next one.